All right, the last time you guys were with us, we tore down the copper truck, took the cab off, took it all the way down to the bare cab, took the bed off, and pulled the whole rolling chassis outside. And actually we've sold that chassis since the last video. And Dylan's been doing a ton of rust repair on the cab. We got some bits and pieces mounted on the chassis. And now today, all the fun stuff starts to happen. We've got a giant crate of horsepower. We got our transmission, headers, adapter plates for the engine. And so now we get to mate all that, put it in the chassis, and we're gonna mock up the cab, make sure the engine can get set back like we want to. So this is where all the fun starts to happen. Let's get after it. Moroso made him breather tanks. Yeah.
That's cool.
That is cool.
I am taking these valve covers off because we're going to put our strap on top of it, and we don't want them to chafe all the Cerakote off the top of the valve cover. Try to make it as nice as possible.
Gonna unhook that and lay it on top for now. So this engine from Don Hardy has been a plan ever since the initial concept of this entire truck project. The owner, Emin, has had multiple Whipple supercharged vehicles and loves Whipple superchargers, and has had 427 power vehicles before, and in my opinion is also a great LS engine to have. So what we did is reached out to Donald Hardy right away and told him what we'd like to build. And there were some things about this build that took a long time, things that we had to wait to become available to us. So the dart blocks are kind of hard to get and sometimes take a bit of a lead time. So this is the raised cam aluminum dart block, and then this is the dart cylinder heads as well. And as you can tell, this is one of the inverted Whipples. So this is the newer Gen 5 design, which took quite a while to get. We started talking to them about this supercharger 2 years ago, and finally got it about 6 months ago. So what they did was they started working backwards from all the newer vehicles, Coyote applications, newer pickup trucks, LT engines, and then they worked their way back to the LS engine. And so once they did, we finally were able to pick up one of these new 3 liters. So this thing has made incredible power. On Don Hardy's dyno, it made 1,006 crank horsepower on 10 pounds of boost. So very huge numbers comparatively for the amount of boost and amount of displacement that this engine possesses. And he was dynoing it on an 1 7/8 set of headers. So we've got 2-inch primary headers that'll help. And then we've got the ability to pulley this engine differently if for some reason we ever wanted to turn the boost up. But I think that we're gonna be more than enough horsepower for what this truck needs. So what we're gonna do now is kind of jump into the transmission, mating it to the back of this engine. So if you guys haven't met Joe, well, I know you haven't met Joe. Joe's brand new. Today's his first full day here. He did a working interview last week and he's here today. So congrats, Joe, for working with us. Anyways, he's unboxing a bunch of Domiworks products. There are a lot of manufacturers nowadays that are creating adaptation parts for the 8 HP series of transmissions to about every engine known to man right now. We're using the Domiworks stuff because really it's tried and true. Domiworks has been making this specific adapter and converter adapter for a long time. So I'm not trying to re-walk some kind of learning curve with a new company making a new adapter. Been down that road before and I don't want to do it again. So this stuff is top notch. and I'm very happy with the quality. So what this adapter is it's gonna adapt the bell housing of the Chrysler 8HP 90 to the back of our LS engine. And this is simply a flex plate to converter adapter. It's got multiple different bolt patterns for different different GM flex plates, but we are using a 6-bolt flex plate, and we're gonna order like a nice SFI one, but then this bolts to the Chrysler torque converter. And right now we just have the factory torque converter that came with our Hellcat transmission, but now there are torque converter options for these engines too. So I will probably actually be ordering the Circle D billet triple disc converter. They make one now for the 8HP 90, which has a, I think like a 2000, 2200 stall, which will be just perfect for the weight and amount of horsepower that this truck has. So this is the adaptation parts. Other Domiworks products that we grabbed was just a little manifold for the cooler. Now we've got a CNR cooler that has 2 electric fans on it, so we'll actually force cool the fluid to the transmission. And then we've also got a new yoke for the output shaft. And what's cool about these is that they go ahead and put grooves in it so we can put a speed sensor off the back of these. These transmissions never had an actual speed sensor in the transmission, so we'll mount an external speed sensor to grab vehicle speed off the back of the transmission. So that's the Domiworks products. These are just products that came with Donald's engine, starter, and breather tank. So I think what Dylan's doing is he's getting the engine mounts on so we can set it in the frame, and then me and Joe are gonna go ahead and start throwing the adapter parts on the bell housing. Okay, so trans to adapter and adapter to the engine. There's some really unique stuff about this engine. I've never been around one of these dart blocks, but like just looking, there's not like a lower rail and then the side bolts to the main caps, which is kind of neat. It does have the LSX style, LS7 style bolt pattern on the cylinder head for extra clamping force. And then it's even got like these ports in the back. I guess these are like freeze plugs. Pretty neat. There's also no instructions for this, but I think we're smart enough to figure it out. So for now, I'm not gonna put the flex plate adapter on or the flex plate. We're just gonna mock all this stuff up. Ultimately, when we take this whole truck back apart for like paint and powder coat and everything, we're gonna send this transmission out to a guy to go through and just like look at everything, double check everything, and upgrade anything that needs to be upgraded, which from what I understand is very, very minimal. Like our power level and weight of the truck, and this being an 8HP 90, there's like very little to do to make this thing live. So for now, I'm just gonna mate it to this, and me and Dylan are gonna go ahead and put it in the frame. So I'm sure there's gonna be questions like, why did we do an 8 HP transmission over a 10-speed or over a stick shift or whatever? And the answer is because this is currently, in my opinion, the best multi-use transmission that you can buy for a reasonable amount of money, and still paddle shift it or shift it like a sequential. So a lot of guys want to be able to go do track day stuff, and they want to have a very fast shifting transmission, and then they also want to be able to drive it to work or let their wives drive it. And this transmission is just kind of like the progression of technology in these series of transmissions. We did the DCT and the OBS truck previous to this. And this one is actually a little more streetable and out of the box can hold more power than the DCT. The DCT is a direct connection to the engine, so there is no torque converter or no clutch and pressure plate, whereas this transmission shifts very, very similar, but it has a torque converter. So the streetability and like the manners in traffic are much better with this transmission than the DCT transmissions. This one has a little more internal mass, so maybe the shifting isn't quite as lightning fast, but these are still really, really fast shifting electronic transmissions. So in my opinion, this thing is like the bee's knees, man. Like he'll be able to do track days and then put it in automatic mode and drive it home. So that's why we chose the 8 HP series. Now, before you start asking even more questions about how easy this is to use, it's easy to bolt it up. electronics are a little more complicated. Not very many like cheaper ECUs can run this thing efficiently. What you run into even with like a Holley system is that it can't blip the throttle blade open enough to do blip shifts. It would just have to do tons of timing change. So Haltech, Motec, Link, any of the more advanced standalone ECUs are what you would need to use with this transmission. So you would have to use one of those ECUs along with the turbolamic controller, which is the electronic portion or the TCU for this transmission. There are others out there, but turbolamic is the one that everyone trusts and is having really great success with. If you want the cheapest option, Haltech probably is the way to go. And all their engineers have been working with turbolamic for like the last 2 years. So all the CAN messaging protocol is the big hurdle, and they have worked together to figure all that out. So if you guys wanted to do an 8HP series, I would really recommend the Haltech with the turbolamic TCU. But we're gonna go a little bit different route in that we're gonna use Motec M150. It's a little more advanced than a Haltech. However, it is a little more expensive, but the tuner that we use is really versed in Motec and Bosch systems. So that's really why we're using that. So anyways, that answers those questions, hopefully.
The engine block on the 427 is a little bit different from the normal LS engines that we've been using, as in it has another casting like tab off of it right where the adapter plates that we normally use are. So I'm just kind of clearancing it. I'm gonna leave some of the in there so it doesn't like jeopardize the structural integrity of it, but we're gonna try to clearance it and get it on there so we can at least get the engine back in the chassis.
So with these motor mount adapters that we're using, that's kind of like the coarse adjustment. And then a little trick that we do is when No Limit builds these chassis for us, we tell them to not weld the sleeve for the engine mount. So this gives us a bit of like finite adjustment. So if we're kind of between holes on the adapter plate, then we can just slide the engine back and forth. And then while it's in there, we can tack these, pull them out, and then weld them all back up. So yeah, so if you're trying to order a chassis, at least if you order it from us, we never weld these. So if you're mad at me because yours aren't welded, that's why. So you can move it back and forth a little bit. Yeah. Not often you see it too. They're not gone. Oh, I feel like I'm on a rock or something.
So I could see. There we go. Stop there. Oh, shit.
Yeah. I think we'll end up needing the 4L80 cross member that Rob sells. This is the T56 one, I believe. And so we need to go back a hole. I feel pretty good about where it's at right now.
Yeah.
Let's make sure the headers fit. I'm worried that the header's gonna hit this adapter. The adapter sticks out quite a bit.
Yeah, I see that over here on this side.
It's a big girl. So these are from Ultimate Headers. These are their mid-length headers and 2-inch diameter primary. So these ought to be pretty good for the amount of power. And a lot of people get all worried about us not running like a long tube, but a long tube header only creates low end torque. And we obviously need no more low end torque than what we've got here. So a mid-length is perfect for a blower motor. This side looks good, Dylan.
Does it?
Yeah.
The head studs are, they're touching the back of the header, but we don't have any gaskets on here at the moment. So we'll wait till we get gaskets, and hopefully that just spaces it out just enough to clear them.
I'm putting the valve covers on because we need to set the distance of the engine front to back. And that location is going to be dictated by the amount of firewall that we have to cut out. So I'm putting the valve covers on, he's putting the cab on the lift, and then we're going to mock up the cab. And we're just going to have to keep like trimming the cab out until we can get good clearance around these valve covers. But yeah, like we've built a couple of these trucks now with these big valve covers, and once you get the adapter plate and these big valve covers, it's wide, so we have to widen the opening in the firewall.
These are the old wheels that used to be on Capone that one of our buddies purchased, and they're just sitting here. So we're going to use these in the meantime so that we can move the chassis and test fit the cab. Make sure that it doesn't mark.
Wheel spacers, just so we can try to get the wheel past this bearing. Because this is the bigger Silverado bearing. There we go. Good there? I'm gonna have to actually get the instructions out because I don't remember which is front and which is back. I don't know who typed these instructions, but they did an excellent job. Okay, the back ones are the thick ones. So these go on the rear. So I know we're gonna have to trim this firewall, but I'm just gonna put it down so you guys can see what we're gonna do here.
We've got to move the frame back like 1.5 inches.
Okay. All right, well, if you guys wanna check this out, I'll show you what we're gonna have to do here. This side is the side that always needs the most amount of clearance. But as you can see, like this big valve cover, like it's gonna interfere with that. So we did the same operation on Wes's blue truck, if you guys wanna look at any pictures on our website. So we pretty much take this bend and just move it all the way this way by about 1.5 inches. Okay. Well, you want to lift it up and then cut that side out, and then we'll try it again?
Yeah.
So what we're gonna do, guys, is we're gonna take this surface and extend it that way. So all this will move over to here. So right now, Dylan will just come in here and kind of trim out like this, and they'll trim out around here. And then on Wes's, we had to make this a deeper, I don't know, like a greater radius, or excuse me, reduce the radius. Since this radius is so big, we had to make it more pointy in the corner. You got the ground yet? Keep going, you got room. Keep going if you can.
Hold on. That's good.
There. Shove it back. That'll help.
Yeah, the frame's gotta go that way. Yeah, you're gonna have to cut that. You have to cut out in here. If you don't, you'll never get this off.
Right, yeah.
Okay. That means we've got this motor quite a bit back.
Yeah.
More than we typically do.
For sure.
That being said, it could probably stand to come forward like a quarter. I'm gonna mark that mount so we know how much we've moved it.
Okay.
This is the beauty of not welding that tube. So now we can just slide it a little bit and make another mark and weld them. Yeah, this whole footwell, whole toe board's touching. Have you got room to pull that header out of there? I'm happy. I'm happy that we were able to get this motor back that far. It's further back than what we've done in the past, but I really like that.
So close.
I know, it did not touch. You got a knife, Dylan? So this is a set of ultimate headers that are specific for the OBS trucks. And we had, it's this one. Just take that one out. So we helped ultimate headers figure out how the primaries needed to be routed on these. And we kick the collector and this pipe, I believe, this way to get it away from the toe board. It's hard to see like this, but you can see this side, how these pull this way. That should give us a lot more room. Oh, ready? 1, 2, 3. Nope. 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 That's too heavy. I'm gonna let you do that. I'll do this. Look and see where your mark is. I made a mark on that tube. Bump the engine in the mounts a little over 1/4 inch. So just trying to like really fine tune where we got it or where we want it. So Dylan's just making sure that the whole transmission, the transmission is centered. So we make sure it's not angled in the trans. And then we're kind of like right at our limit of where we need to be. Like I can't come forward any and I don't want to come forward any.
So this is the 4th or 5th time. I lost count. But we had the header that was hitting the toe board, so we cut out the toe board. We've cut sections out of the firewall so that we can get the engine back as far as we possibly could. We actually moved it forward about a 1/4 inch from where we had it to try to gain more clearance on this header. And so now we're gonna test fit it again. And then hopefully we got it dialed in this time. And then of course, we'll go back through and reshape all this and smooth it out real nice. Yeah, it's gonna have to go all the way.
But I would just cut kind of across here and then turn and come down this way.
Okay.
I'm gonna let you check things real quick. You're not touching anywhere on the center, are you, Dylan?
Yeah,
Oh, you are?
at the very front here.
And the trans cross member is like easy. Like the angle of the motor and trans is really good. So all I gotta do is remake that cross member to move it back that set of holes and make it for the Chrysler transmission mount bolt pattern. But like motor and trans went easy. Firewall, we knew that was gonna happen.
Yeah.
The only thing I didn't foresee was
The header.
the fact that we moved it back enough to get the header close to the floor. And on that note, we'll see you guys in the morning. A new product that I'm really excited about is our map relocation kits. Now these won't pertain to a lot of people, but if you have one of the carbon PTRs, or if you have one of the LSX high rams from Mast, or even a Holley high ram, mid-rise, or low ram intake manifold, they all share a common 4 1/8 bolt spacing for where the lids are. And the reason why we're making this map relocation bracket is specifically to move the map sensor out from under the intake manifold and put it in an area which is more accessible to you. So if you're at a racetrack or an autocross, or even on the side of the highway and your map sensor decides to fail, especially on the carbon PTRs or the Mast intakes, that map sensor is located under the intake manifold. So you would have to remove the intake manifold to replace the map sensor. So we have a company that we've partnered with. They make a billet mount that allows you to mount remotely a Bosch style map sensor. So this is your LS3, LS7, LSA map sensors to it. And then we include a -4 AN adapter and then hardware. So if you want that, you can buy it directly from Dedicated Motorsports, or we do inventory them and you can include them in your bracket kit. So the standard bracket kit is our laser cut, broke, and powder coated bracket that has a nut welded on the back so that you can mount this and only this to our bracket. So the basic kit is the bracket with the hardware. And then if you want the deluxe kit, what we do is we add in that billet mount, the AN fitting, and another bolt to mount it. So this is a great product. It really doesn't do anything performance. It just gives you a greater accessibility to your map sensor in the case that it fails and you could just simply replace it. Another great thing about using this style of a mount sensor relocator is that you use an OEM style map sensor. So there are other remote map sensors available, but they're kind of only aftermarket style map sensors. With this style of map sensor, you could simply stop at a parts store to get a new map sensor. So anyways, these are on the website, ton of them in stock, check them out. All right, we're back after it this morning, guys. Yesterday was a really good day. One of the biggest objectives that I had for the day was to locate the engine and transmission in the chassis and know that that's permanently where they're gonna live. And mocking up the cab is what we had to do to determine engine location, and all that's good to go. So now this morning what we're gonna do is pop the headers back off so we can get in there with a TIG welder and TIG weld our tube sleeves for our motor mounts and lock them in place. And then we're gonna also redo the transmission mount. Now, keep in mind we have an 8 HP 90 transmission, and No Limit doesn't offer a cross member for that just yet. So what we did is we just ordered a flat, plain, basic cross member that they offer. That's just kind of like a builder's cross member, and it actually needs to move back. So Dylan and I are gonna pop it off and re-drill the holes and move it back today. And then engine placement will be done. We can mark that off the list. And then Dylan has also made some notes, not only on the cab, but in paper and pen, to tell himself how much distance he had from each cut on the firewall on both sides to the valve cover. So when we get this cab back off this week, he can go ahead and start redoing all that pocketing inside the firewall. That way the engine can sit where we've wanted it to be. The other big thing for today is to put the fuel tank in the frame. I want to talk to you guys about our fuel tanks and how we make our fuel tanks and why we make them in the way that we do. And we're going to talk about fuel pump sizing, how many fuel pumps we have and why we did that. And then I've had the tank all welded up for a while, and then now today we're going to go ahead and put the mounts on it and bolt it into the chassis, and then hopefully I can make the fuel plumbing hoses too, so they go from the tank to our hard lines on the chassis. So if we can get the fuel tank in and located and done, we can check that off the list, and engine placement checked off the list, and I'll feel really good for the last day and a half, 2 days. So anyways, I'm gonna finish this coffee and we'll get right after it. Dylan's grabbing his angle finder so that we can check the pinion angle on the engine and transmission. Now this one, you can either view this one way or the other, but it is, it's not quite as important, or it is very important to get the engine driveline angle just right, because our rear end is not going to move on this one. So it's a little easier to do, I guess, is what I'm trying to say, because we don't have to talk about any kind of pinion change. The rear pinion stays the same, the transmission's going to stay the same, and then we've just got to get the angle of the drive shaft to give us our formulas of front and rear U-joint operating angles. So before we finish this cross member for the transmission, we're just gonna make sure that the engine is at a nominal angle for our independent rear suspension. We essentially want it to aim kind of right at where the yoke of the third member in the rear end is gonna be. So like on my yellow and white truck, what, Dylan, it was probably 2 degrees or something?
Yeah.
It wasn't much at all.
Yeah.
So just by looking at this, it looks like it's around 3. And if you look at where the transmission's at in comparison to the floor of the truck and the inner part of the chassis, this transmission can't come up anymore. The drive shaft won't clear. Well, right now it won't clear at all on the floor, but I don't want to have to go and cut this part of the chassis out. I mean, we may have to, depending upon what these angles are, but if we can keep from having to do that, that'd be fantastic.
2.9.
Angled up?
2.9 up.
Okay, we're 0. What'd you get down there? 2.2?
2.2.
Yeah, 2.2. It's flashing 2.1 to 2.3, so. So the engine and transmission are angled down at 2.2 degrees, and we know that the third member carrier is angled up at 2.9, but the big variable is the angle of the drive shaft, and that dictates the operating angle of the joint. So Dylan's gonna grab the third member and throw the third member in, and then we're gonna simulate a drive shaft with like a piece of PVC pipe or a string. So in the meantime, let's hop over. I wanna talk to you guys about the fuel tank and pumps and all that stuff. So we already welded up the tank. I call these our 12-chamber tanks, and there's 2 stories, so to speak, inside these, and then there's a divider that's horizontal. I got it laying on its side right now. So there's a divider that's horizontal. There's a center vertical, and then 2 verticals this way. So it gives each layer or each story 6 chambers. So there's 12 full chambers. And then we do these billet tops because we were first attempting to just have a sheet metal tank complete, and then we would machine or buy machined flanges for our pump hangers and weld them in. And it was really hard to weld those in and not warp the top of the tank and keep them looking really good. And then same thing with like all the vent fittings and everything. any amount of welding on the top plate would warp it. So what we did is we started designing our own billet tops. And so that way everything's machined into it. And it's only an 1/8 inch thick. So it's the same thickness as the sheet metal in these pockets. But then we've got some strength added in it and an O-ring groove cut, you know, to seal the pump hanger and everything. But the real magic is inside the tank. So the horizontal divider, we cut a hole in it so that the pump hanger can hang down in there. And with these pump assemblies, they have an internal surge tank, and then they've got an external pump too. So the pump that's outside the surge tank will lift fuel and fill the surge tank, and the surge tank will stay full at all times. All the rest of the dividers in there are to control the movement of the fuel. So fuel is approximately 7 pounds, 8 pounds a gallon. So at 25 pounds, that's a lot of weight in the tank, which isn't a bad thing necessarily, but its quick movement could be upsetting to the dynamics of the vehicle. So if you had all that weight that could slam all the way up against each side of the tank, you could feel that in racing or autocrossing. So we want to slow the movement and make smaller chambers of fuel slosh, so it's less weight transfer or less weight movement in the tank. So that's why there's so many chambers. And luckily enough, I was taught by some fluid dynamic engineers of how to control the movement. So there's simply just small holes in the sides that'll control or allow movement of the fuel from chamber to chamber. But then on the horizontal divider, there's 3 holes per corner that allow the fuel to, when it gets to a corner, drop down to the lower section. So, and it doesn't need to be able to move very quickly from chamber to chamber. With the fuel returning from the engine and that sump, you know, the surge tank staying full, you know, it doesn't matter that the fuel doesn't get into this main chamber very quickly. So that's why we do these. That's the theory behind them. And yeah, so this is all done and welded up. I'm gonna go ahead and weld on all the mounting that we designed for it. And then once that's done, we can weld the drain bung in and put the tank together. So the pump assemblies that we've been running for the last couple years are from Radium. Radium started making the FCST, and then they've progressed into the FCSTX. Where they got to in this pump assembly is that they're manufactured in a way that you can change the pumps very quickly. And a lot of that was for Formula D. Those guys only get a couple minutes to do a repair on their truck if they call it a competition timeout. So they're able to just take out a few Allen screws, pull this hanger, and all the pumps come out all at once, and you can grab another one out of your trailer and throw it in. So in just a couple minutes, you could change all the pumps. That's not a big thing to us. The big thing to us is its surge tank. This is where all the fuel is gonna be housed that the engine runs off of. And then when it returns from the regulator, it dumps in here too. And then the surge tank or the lift tank that's down in the main tank will lift fuel and drop it in here too. So the surge tank will always stay full. So whatever high G load that the truck's in, it'll never starve the pumps. So Iman does plan to do a lot of road racing. So fuel starvation was key. And that motor makes over 1,000 horsepower on the engine dyno. So we've got it housed with 2 Warborough 450 pumps in here. And only one pump will run primarily, but when we get into higher boost and load and duty cycle, it'll cycle in the other pump. And then we can also set the PDM to where it could disactivate or deactivate one of the pumps if it sees a circuit failure, or if the fuel pressure just won't stay where it needs to stay, it could just shut that pump off and run the other pump. And then we could program in safeties to where it wouldn't allow the engine to rev or take timing out if it sees, you know, a lack of fuel pressure. So 2 450s in here, and then there's 1 450 that'll sit down in the tank, and that's what will constantly keep the surge tank full. So anyways, that's what we're doing here. That's why we do it. And yeah, so let's get to work getting this thing done. Deburring my bunghole. So my kids play Fortnite all the time. And recently they're like, you know who Beavis and Butthead is? I'm like, yeah. And they're like, he's so funny, pulls a shirt over his head. Yeah, so I watched some Beavis and Butthead with Charlie. I thought it was hilarious. Okay, this is just a random. Random pipe.
You want to toss me a tape
Let's
measure?
take a length measurement.
Yeah, could you hand me a tape measure? Could you hand me a tape measure?
I'm busy. You can slide it all the way back to that. That way you just got to hold one end if you want.
Okay.
So if you guys notice, the key here to making sure that all this is right is to use 0 off the frame. So don't reference level of the ground, reference the frame as your 0 point. You ready?
Yeah.
Okay, 1.55 uphill.
Okay.
All right, so this is why the variable of the drive shaft angle is so important, because we're not comparing these two angles. I've read tons of articles where people say that these just have to be parallel and that's all that matters, and that is completely wrong. The joint operating angle is what you're looking at, not the angle of the components. So, for instance, if our drive shaft was completely flat and the trans was down 2.2 and the rear end was aimed up 2.9, these are the things that you either add or subtract. The drive shaft to the rear pinion or the drive shaft to the transmission angle. Since this is 0, that makes the operating angle of the joints 2.9 and 2.2. Here are the rules to follow. These two joint operating angles have to be as close to each other as you can get them, no greater than 1 degree apart from each other. And then for the higher the mile an hour stuff, the least amount of angle, the better. Now you never want 0, but if we could get these to close to like 1, that'd be great for a vehicle that wants to go higher mile an hour. If you're a rock crawler, those dudes don't care. They put them at 6 degrees because they're never gonna run a high enough mile an hour to notice any kind of harmonic in the drive shaft. So we are technically within the rule if our drive shaft was 0. So the variable is the drive shaft. So 1.55 degrees on the drive shaft is where we're at now. If the two components that you're either adding or subtracting are on the same angle, you subtract them. If their angles oppose each other, you'd have to add them together. So for instance, if this rear end was aimed down at the ground 2.9 and the drive shaft was aiming up the other direction at 1.55, you'd have to add those together and that would be your joint operating angle. So since ours are on the same line, we subtract them. So 2.9 minus 1.55 is 1.35 here. And then 2.2 minus 1.55 is 0.65. So we do have, in my opinion, a little bit of an issue here. 1.35 minus 0.65. So they're within a degree of each other, but they're 0.7. Them being this low of an angle probably isn't a problem, but I'd like to get them closer. So we have to think about what would change, right? So if the rear end moves down, if we pinion, let's say we pinion the angle of the rear end down to 2.6, this is just a guess because we don't know the effect it's going to have on the drive shaft necessarily. It will increase the angle of it. So let's just say it goes to like 1.9. So what would that be? 2.6 minus 1.9 is 0.7 there. And then the 2.2 is not going to move because that's a transmission. 2.2, so that's 0.3, right? Minus 1.9 is 0.3. Ooh, so that would get really good. I would like that a whole lot. Then the transmission doesn't need to move.
Yeah.
So all we need to do is bring the pinion of the rear end down just a little bit. But let's see how to do that. So if we just bring the trans down, that would do a lot too.
Yeah.
So we're already too high in my opinion on the trans, so bringing it down would help everything.
Right.
So right now on that transmission, we've still got the mount that came with the transmission. So that's the Chrysler mount. Now there are aftermarket mounts that use like the good old fashioned GM style transmission mount. And we could always make or buy one of those and then just use our traditional trans mount, the GM trans mount. So then it would mount to our slotted holes in the cross member. And then we could essentially shim or take that down.
Yeah.
That's just a bunch of cast aluminum.
Okay.
So that's probably the ticket, is to take that off.
And use one of our,
Yeah.
the ones that we typically use.
That way we can drop the trans a bit. Did you guys follow that? You know, this will also help our header clearance too.
Yeah.
We're gonna use a billet pan anyway, so.
Okay.
We're gonna shim this cross member down to get to our target of, what was it, 2.6 degrees? And then see what the effect is on the drive shaft. Hopefully it'll bring it closer to 1.9 degrees.
Okay. The face of the pulley is 2.7.
Okay, let's try that.
Yeah,
So Dylan, I think what we should do is leave the trans right where it's at right here on this jack stand.
Yeah.
Pull the headers off and then TIG the sleeves where they're at.
Okay.
It don't impress me much. Okay, so this is where we started out. So this is the transmission side, this is the rear end side. Started out at 0.65 there and a 1.35. We had a theory of being able to change the rear, and that would affect the drive shaft angle, and that would get us really, really low, but honestly maybe a little too low to keep them lubricated and cool. So the easy thing, and the thing that helps us the most, is bringing the transmission down actually and increasing that number. It'll give us more clearance in the tunnel. This is where we are now. So we were able to drop the transmission a little bit, maybe 3/4 of an inch, and that increased our angle by 1/2 degree there, but it decreased the shaft by 3/10 of a degree. So 1.2 minus 2.7, or 2.7 minus 1.2 is 1.5 on that. That effect made this 1.7. So it brought that one up and brought this one down and got them really close to each other. So them being as close to each other as possible is very, very important. And then being right around 1.5 degree is also really good. I mean, this truck will be able to go 160, 170 miles an hour with no drive shaft vibrations at all. So what we have to do to get there though is redo the rear transmission mount brackets. So we're gonna redo that out of steel and use a GM mount. And that way we can move it up a little bit, flat transmission cross member, and then we're good to go.
So what we had to do for the 8HP90, because we wanted to use the transmission mount that we typically do, so we made a whole new, brand new mount. This is the old one, big and bulky. It's set up for the Chrysler transmission mount, so we just went ahead and made a new one. So now we're gonna test fit it. I just tacked this plate onto this one. That way I can kind of make sure my height is right. So we're gonna put this in, set it down on the cross member, check the pinion angle again, and if everything's good, then we'll burn this in, and then this will be completed.
Perfect. I think it looks perfect. Probably have to like notch this cross member out that's in here, like remove some link to get the hoses to go through here. But I think it's good. Ready?
Yeah.
How's that look left to right?
It looks pretty decent.
It fits great. Whoever designed this is brilliant. Like a glove. Jake, you should tighten that nut. All right, well, I don't need to put the O-ring, and I don't need to put the lift pump in, but I am gonna go ahead and put a few bolts in so that I can like make the main hoses. All right, well, I've got these clocked like I like them. So I'm gonna crimp one end of each hose, slide heat sleeving on, and then I'll crimp the other end, and then this is pretty much wrapped up. I like to always clock them to their natural arc, so you're not trying to like go against their arc to make them land where you want. Boom. Right on the money. I haven't crimped this one yet because I just want to verify that it's like perfect. I'm gonna grab a couple zip ties and that's done.
So now I am taking the headers off of the engine because like we showed you guys earlier in the video, we don't have them weld the mounts into the frame, and then the mount that the engine mount actually goes to, it's just a sleeve that slides back and forth. So we left all that. We tacked the mount to the frame and left a little tube free so that we can move the engine back and forth. So now that we got the engine placement where we want, and we got the pinion angle and the trans mount set, I'm gonna pull these headers out and get in there and try to TIG weld around that sleeve as much as I possibly can with it in the truck. That way it doesn't move again and we can go right back to where we were during mock-up. I'm gonna go ahead and pull that trans mount out and go ahead and finish getting that welded up. That way it can go back in for good. I think we should be good. We'll be ready to pull the cab off after this, and I can get started on the massive amount of sheet metal work that you guys can see needs to be done. And Jesse will just keep plugging away on the frame.
All right, we did it. We checked off the 2 boxes that I wanted to get checked off. And I think it was good content for you guys. Maybe you learned a couple little things about pinion angle, U-joint operating angles, and why we make these crazy expensive wild billet fuel tanks. But thank you guys again for watching. As always, our 1,000 horsepower Don Hardy engine is permanently in its place. The engine mounts are TIG welded. The transmission mount is built, the cross member's in, and we were able to use the no limit cross member, right? Like it went right on that? All right, so for you guys that are ever gonna do a no limit chassis with an 8 HP 90, we got you. The mount, the transmission crossmember that they offer, it'll all work. And then the fuel system's done now. Like it's plumbed up into our bulkheads. So now all I got left to do is regulator, crossover hose, and then soft lines back to the chassis. So this is a blast of a project. Oh, also, thank you so much for all the recommendations of names for this truck. Officially, it is Midnight Sun. It's great actually, because he's from Alaska and they have those days where it's sunny or the sun is up, not really gone down for 24 hours. So midnight sun is a bit of an homage to him coming from Alaska. This truck rolled in here with Alaska plates on it, so it makes sense to us. I like it. It has nothing to do with copper or pennies or anything like that, but this will now be known as Midnight Sun. So anyways, thank you guys so much for watching. I think next time you watch this, the cab will be done and we'll hopefully have the bed on and start to do, I don't know what, maybe some exhaust building, wiring, who knows. But anyways, thank you for supporting the channel as always. And then if you can, comment on this truck, how much you love it, hate it, learned, want to learn in the future. Anyways, I'm going home.